Today, we are going to find a polynomial expression for the inverse of an n by n matrix using the Cayley-Hamilton theorem. Let's begin. We're going to set the matrix A equal to 1, 2, 3, 4. To find the characteristic polynomial, we will calculate the determinant of t times I2 minus A, where I2 is the 2 by 2 identity matrix. Performing the calculations, we get that f of t is equal to t squared minus 5t minus 2. Now, using this equation, the Cayley-Hamilton theorem simply states that f of a is equal to the 2 by 2 zero matrix. With this, we can actually go ahead and find a polynomial expression for the square of this matrix. By moving the 5a and 2i2 to the right side of the equation, we get that a squared is equal to 5a plus 2i2. Now, to actually calculate the inverse of a, notice that the definition of the inverse states that a times a inverse equals I. So, using this, our first step is to move 2i2 to the right side of the equation. Next, if I factor out an a on the left side, I get that a times some other matrix equals 2i2. Lastly, dividing by 2, we get that a times a minus 5i over 2 equals I. And from our definition, that implies that a inverse is equal to a minus 5i2 all over 2.